Let's take a look at how we can find derivatives of polynomials. All right, so if we're given a polynomial, primarily what we need to understand is how to apply the power rule. Okay, now the power rule is pretty simple. It is one that tells us that if I have a monomial to some power, all right, so in this case, my monomial is, let's say, x, to some power n. If I were to take the derivative of that, the derivative would be n times x to the n minus 1 power. Okay, so it's rather simple. If I give you a basic example, let's say x to the fifth. What this is trying to say is that if I take the derivative of x to the fifth, then 5, which was the power, becomes now the coefficient, right? So 5 essentially gets brought down to the front times x, and then we subtract 1 from the 5. So if we subtract 1 from 5, we get 4. So that's essentially the process for the power rule. If we apply this now to polynomials, we can then find the derivative of longer polynomials. So if we're looking for the derivative of f of x, then what we want is f prime of x. Okay, f prime of x, that's the typical notation. So we need to apply power rule to several of these terms. So if I look at the first term, negative 20x squared, I know that that means I'm going to need to take 2 and bring it over to the front and multiply it to whatever coefficient might be there already. So then what's that going to turn it into? It would be 2 times negative 20, so we actually get negative 40. I still have x, but I need to drop the power by 1. So instead of a power of 2, I subtract 1 from that, I end up with x to the power of 1, right? Now, since it's the power of 1, I don't need to write it. It's just there. All right, now we do the same thing here with 27x. 27x has a power of 1. You can see how if I were to apply that power rule, it would be 1 times 27, so it's plus 27x, but it's 1 minus 1 power, so that's x to the 0. So then x to the 0 is simply just 1, right? X to the 0 is 1. So that ends up just being 27 times 1, and then the rest, negative 40x. All right, so in this case, what the derivative will end up being will be negative 40x plus 27. Why did I not approach the constant? One of the typical rules is that the derivative of a constant, for example, is just equal to 0, okay? There is no rule, let's say, to apply the power rule here because there's no variable x, right? So we want to apply this pretty common rule that if you take the derivative of a constant, it's equal to 0. Therefore, that's why I did not necessarily apply anything to it. But if we did, this would just have been add 0, add 0, add 0. If you add 0, it's still just going to be 27. So the final derivative here is negative 40x plus 27.